Hi, today I will show you how to simulate investment casting process in casting simulation software PoligonSoft from Russia. And here you can see PoligonSoft shell, and I will start with meshing of my geometry. And now I run mesh generator. Go to geometry model and import my geometry in step. And here it is. I will press no because I have my model in millimeters. And create partition, yes. Contacts between all bodies in my geometry, and I have 8 parts and 1 down sprue. And I will rename it here like this. And then go to mesh module. I will try to create a shell. So the main shell I will create from this partition object. Go to the 2D tab to create 2D mesh first of all, and select NetGen 1D 2D algorithm and create new hypothesis. Here I set maximum element size 6 millimeters for down sprue and 1 millimeter minimum element size, and finesse is coarse. Okay, and close. And this is common rules for my 2D mesh, and I want to create more accurate mesh for casting parts. So I click right button my mouse and create sub mesh for my mesh 1, and geometry I select from this tree only casting parts. Go to the 2D tab and select algorithm again 1D 2D and new hypothesis, and maximum element size here is 2 millimeters and minimum element size is 1 millimeter, and finesse is coarse. Okay, plan close, and I will try to generate a mesh for casting pads first of all. It's okay, and I can see my mesh. I think it's okay for our example, and I will generate other mesh now for down sprue. Oh, and I have a mistake here. Problem in surface mesh generation in the phase number 5851, and I can see it. It's here. Something wrong is on this surface, and I can turn off mesh and turn on down sprue geometry, and I see this radius. It is very small. It's better to delete it in CAD system because you can see contact between casting part and down sprue is not good here. But I will try to repair it in this mesh generator. So I need to close and to delete my mesh and return to geometry module and delete partition object and delete all these bodies. I need only this first object. It's my imported CAD file. Here it is, and I will repair it. I go to repair menu and shape processing command and apply and close here. And I see that some 4 edges were corrected and they were intersecting. Okay. And now I have new object, process shape, and I will work with it. First of all, I will explode solids from it. Here they are. And now I will create partition. I will find all contacts between these bodies. partition and apply and close. All these operations were done automatically when I imported the step file, but now I need to make them in manual mode. And here is a partition, and I need to explode it again. Select solid. Yes, and now I have new repaired geometry, and here is a down sprue, and I go to mesh model and try to repeat, create mesh from new partition, 2D tab, and select algorithm and hypothesis. I have my hypothesis. I prepared it. Here it is. And create submesh again. Apply and close and generate submesh first of all. It's okay. Now we'll try to generate mesh for down sprue. And that's the problem again. And I will try to change hypothesis. For example, I will change finances to moderate. Try again. And I have success. Here is my mesh. And now I can check it. Check mesh quality. Press this button. I can try to correct these bad elements. Press correct. A lot of small edges in my mesh because there are a lot of small radiuses in model, and it's better to delete them before meshing. Correction is finished, and I see that I have 8 elements with bad triangles and a lot of small edges, but I can to repair them. Okay, close this window and try to create 3D mesh. Okay, we have a success here, and now I will close this report, and I need to create groups of my 3D elements from geometry, and I select this command and select all bodies from my geometry here. Click apply and close, and I have these groups with 3D elements, and now I can export my mesh. Click here, export to med file, and here is the name of my mesh, and save. And that's all. I can save my work in mesh generator format like this. Now I can finish here. I can close mesh generator and start PoligonSoft preprocessor master. Here I open my mesh in Salom and units millimeters. Okay, and I select this file. I have no special simulation parameters loaded, and so I can click no. In PoligonSoft, gravity vector is directed against y-axis, so I need to rotate my model, or it's better to say I need to rotate coordinate system. So I can click here to reset rotation, and I see that in right coordinate system position, I see my casting like this. So I need to rotate it around the x-axis. I can click this button to rotate, and rotate coordinate system, fix rotation. Yes, now I see my casting in right position and coordinate system in right position too. So I click this button volume type mode to see what is casting and what is mold, and red color is casting, and here it is in my tree. Sorry. And the other bodies are in mold, and it's wrong. I need to replace them to casting tree. So I can click on my down sprue and I say that it's a casting type, and I can select some index, for example, index number 2. Yes. And I see that now down sprue is casting type, has a casting type, and I can select other parts and press enter button. And here I select volume type, casting, and volume index 1, for example. And here is the question to set default boundary faces. Yes, let's be yes. And now I see my tree. I have no mold. I need to generate it now. My ceramic mold, and all these parts are red because they are casting type. And in this mode, volume index mode, I see that parts have index number 1, it's white, and down sprue have index number 2. Now I will generate ceramic mesh. So I go to the third mode, boundary index mode, and I see all my boundaries. They have the same color because now these boundaries are with environment, and I need to select boundary where I don't need to create a shell. And here it is. I press Control button on my keyboard and click on this face, and I select it. Now I need to set new index for this boundary, and I press this button, assign face index, and I can select here any index. It doesn't matter now. For example, index 1. Now I press create shell tool, and here is a semi-automatical mode to create it. I checked this inlet area surface index, and here is 1 because this boundary index is 1. Volume index of shell, I can set here any value, for example 2, and index for this area above this boundary with 1 index, and I will delete it later. Let it be 3. And shell thickness 7 millimeters. It's okay. And here is some parameter. It depends on geometry, and for such geometry, small parts and thin whorls, it's better to set 80 or 90 or maybe 100. And I set 85 here and click OK. Now we need to wait some minutes. My shell is ready, and you can see it. It's realistic. And in the volume index mode, I see 2 volumes, my shell and this volume that I don't need. And here it is, and I can delete it. And yes, I want to set default boundary faces. And my boundary faces looks like this. Here is in blue outside boundaries, a boundary between mold and environment, and this red boundary is between casting and environment, and inside we see such pink boundaries between casting and mold. Now I can stop my process, and I go to my simulation parameters and start to fill these tabs. In general tab, I fill alloy temperature, and I know it from customer. It's 1610 degrees, and mold temperature is 1050 degrees, and ambient temperature is 25 degrees. Alloy properties file, I prepared it. Here it is. And I click edit, I can see liquidus and solidus temperatures, and liquidus temperature is 500 degrees and solidus 1457. I need this data. And mold properties file, so some template for such process investment casting. And this template is here in PoligonSoft folder, in BD folder, investment casting on air. And the next row is, the next line is heat transfer file, and I will load the same template for investment casting. Here it is. Now I will close, and I will double click on my mold here, and I see that volume index number 2, it's a ceramic mold, and I will use it. Go to my parameters. Here I can select number of threads that I will use, and on flow tab I will enable flow model and cell size, because we simulate flow with the finite difference method, and I will set cell size 2 millimeters, for example, and output time step for result recording 0.1 second. And here I need to set up velocity file with my velocity, input velocity, and I will take it from our database, for example, 0.8 meters per second. It's a usual velocity, and that's all here. And on solidification tab, enable solidification model OK, and here is a calculation time step, maximum time step 1 second, it's okay, and output time step 10 seconds. I will set up 5 seconds. And the stop criterion is solidus temperature. We will not simulate stresses today, only filling and solidification and porosity. So I will stop simulation on solidus temperature and casting. That's all here. And on porosity tab, macro porosity model and micro porosity model are turned on. And here I need alloy properties for porosity simulation from my folder. Here it is. Yes. And now I will save my project. Save my project to the special folder, and I will create it. Polygon, for example. And I need to set up inlet for filling. And here is Inlet Tool. Create new inlet. Press Ctrl button on my keyboard and click somewhere here. Yes, it's okay. It's too big, and I can set diameter, for example, 20 millimeters. And this inlet will work from 0 seconds and till my casting will be filled. So press OK. And finally, I want to look on my heat transfer data and press edit. And in my project, I have only 3 boundaries. This casting mode boundary and casting environment boundary. Here is a convection, and convection for mold environment boundary, and casting mode. I want to set up curve. Press plus here, and for example, temperature 20 degrees, and heat transfer coefficient will be example 800, and the next is solidus temperature. Next point is liquidus temperature. Example 2000s, and 2000. So I have some curve for my heat transfer coefficient. Here is a value for contact between liquid metal and mold, and here is a value for contact between solid metal and mold. Now I think it's okay. Close it, save. And before I will start my simulation, I want to check my mesh because I created a new mesh mold, and I want to check mesh quality. I have this function here, and I have 4 bed triangles with a small angle in casting and 151 bed element in mold. I can try to repair it. Press repair button, but I think that I can't repair such things like this in my mesh in mold. So I will try to repair some small problems like this, and I will delete these bad elements from my geometry. It's done. And we have 0 in casting and better result in mold. So I will remove other bad elements. You always need to remove bad elements from geometry on the final stage before you start your simulation. So now I can run simulation, save project, and we see that simulation was started. Now it's a filling simulation, and here we can see progress, filled percentage, and the certified percentage, and time. And we can see results during simulation. You can press this button to start post-processor module. I can load velocity field. Here's my geometry. I can change background to white, for example, and I can change scale for this. I will turn off mold and will turn on transparent casting. And now I need to wait while some results will be recorded, and I can change my scale. I think this value is maximum, and here something like this. Apply. Here is a first step, and now we need to wait. Our simulation is finished, and we can show all results. Now we see filling results, and we see velocity field, and here is a scale, and we can use this player to move along the simulation. See filling dynamic. Looks like this. Or we can use automatic mode. If geometry is big, we can record video and look filling process in real time. And we can see temperature field. I can load it. And I can go to the last step, for example, and we can see temperature field on the mold. I think I need to correct my scale. I can correct temperature, low temperature. And we will see mold heating during the filling. For example, outside temperature is 1033 and inside temperature is 1150. Something like this. And we can see filling process temperatures. Want to correct here my scale. Here is a liquid dust temperature, and here is a solid dust temperature. And at the end of filling, we see that here is a solidified places in casting parts, and yellow color is 50% of solid fraction in casting part. Solidification goes quickly. And now let's see on temperature field during solidification. Here it is. Switch off mold, and this is a temperature field at the beginning of solidification, and I can change my scale to percents, and I can load saved scale on my disk. Here it is. So red is fully liquid condition, and the gray color is fully solid. And I can turn on pipe displaying, and we can see. And here I have is a surface mode. It's here, and we will see only that parts of casting where we have some percentage of liquid phase, and the solid phase will be transparent. And we will see all thermal spots. But looks good. There are no hot spots here. But maybe we will see some microporosity in casting parts, and now we will look at porosity. Here is a scale, and the lower level is 0.5%, and high level is 90%. And I go to the final step, and here is a microporosity. If I switch off the surface mode, I see this microporosity on the surface. I think we see it because cooling rate is too high here, and we see some small cavities here. And here. And here. Yes, in every casting part we see this deviation. And as for this microporosity, if casting parts are controlled by X-ray, it will be a problem. If not, I don't know. Maybe it's not a problem. It's hard to say for the first time. And in volume, we can see a picture like this. It's a very, very sensitive level. I can make it not so sensitive. We will see porosity from 1% to 100%, and yes, we see it. And that's all. We don't see it. So microporosity is from 0.5 or lower percent till 2%. I think that for such part with such thin walls, it's not good situation. We need to make something to do these parts clear from porosity. And here we see porosity with a high percentage, and if I will change here to 10%, we will see it. So it's very dangerous. I think it's something like small pipes. So we need to change technology to do something to avoid these problems. So that's all. I showed you how to simulate and analyze investment casting technology. Thank you very much. Bye-bye.